Hello everyone, welcome back to our channel. In today's video, we will explore the EBS volume types. Within the EBS volume types, we have SSD, which stands for solid state drive. We have HDD, which stands for hard disk drive, and magnetic volumes. Now, the SSD-backed volumes are specifically utilized for transactional workloads by frequent read-write operations where the predominant performance attribute is IOPS. So IOPS stands for input output per second. For example, let's consider a scenario where you have an application that requires frequent read-write operations to the database. If the database or the storage device has high I/O capability, it can handle a large number of these operations in a short amount of time, leading to better overall performance for the application. HDD-backed volumes are tailored for large streaming workloads, prioritizing high throughput as a key performance attribute. High throughput. Throughput refers to the rate at which data is successfully transmitted or processed over a communication channel, a network, or a system. For example, let's consider a network environment where you are transferring larger files between two computers, a computer A, a computer B. The throughput in this context would be speed at which the data is transmitted from the source to the destination. If the throughput is high, the files will be transferred quickly, whereas lower throughput would result in the slower transfer rate. Magnetic volumes represent the previous generation of the storage solutions backed by magnetic drives. So these are the previous generation ones. These volumes are best suited where data access occurs infrequently and high performance is not a primary requirement. SSD volume types include general purpose SSD and provisioned IOPS SSD. Under general purpose, we have GP2 and GP3. GP2 volumes can burst. Let's consider an example to understand the burst. Suppose you have a GP2 EBS volume with a baseline of, let's say, 100 IOPS. So you have a volume baseline of 100 IOPS. This baseline represents the standard performance level you can expect from the volume in normal circumstances. Now, GP2 volumes come with an ability to burst, which is governed by I/O credits. So the volume is not utilized, or in inactivity, the EBS volumes accumulates the I/O credits. So it will save up few credits when you are not using the volume. And when your workload demands more performance than the baseline, the volume can use these accumulated credits to provide additional IOPS for a limited time. Let's say your application has a sudden spike in the activity and it needs some 300 IOPS for a brief period. The GP2 volume can utilize its I/O credits to temporarily exceed its baseline providing the required 300 IOPS until the burst credits are depleted. Once the burst credits are used up, the volume returns to its baseline. This burst capability is useful for applications with intermittent or bursty workloads, allowing them to benefit from higher performance during the short burst without having to provision a higher baseline performance. So instead of going for 300 all the time, you can just go for 100. And whenever you want it, the volume could burst. The GP2 volume baseline IOPS performance scales linearly from a minimum of 100 and a maximum of 16,000 IOPS. The GP3 volumes are the latest generation of the general purpose SSD volumes. Now, GP3 volumes deliver a consistent baseline IOPS performance of 3000 IOPS, which is included with the price of the storage. Now, you can provision additional IOPS up to a maximum of 16,000 for an additional cost. And GP3 volumes offer a 20% lower price per GB than the GP2 volumes. So both GP2 and GP3 provide the same IOPS and also same volume size, which is from 1 GIB to 16 TIB, but they differ in terms of their underlying technology, pricing structure, and features. Now, provision IOPS stand out as the most advanced performance category among EBS storage volume types. These volumes are specifically created for mission-critical workloads demanding high IOPS, substantial throughput, and low latency access. Under provisioned IOPS, we have IO1 and IO2 block express. IO1 volumes are available in sizes ranging from 4 GIB to 16 TIB, with an option to provision anywhere between 100 IOPS to 64,000 IOPS maximum. For IO2 block express, the volume size range extends from 4 GIB to 64 TIB, allowing you to provision up to 256,000 IOPS per volume. So it is designed to meet the performance needs of demanding IO intensive applications that run on instances built on Nitro systems. So the AWS Nitro system is the underlying platform combines hardware and software components for optimal performance, availability, and security. Next, we have HDD volumes. The HDD volume types include throughput optimized HDD, ST1, and cold HDD, SC1. The throughput optimized HDD volumes are low cost and specifically designed for frequently accessed throughput intensive workloads with the maximum throughput of 500 megabytes per second. And cold HDD volumes are the lowest cost designed for less frequently accessed workloads with maximum throughput of 250 megabytes per second. And finally, we have magnetic volumes, which are also utilized for less frequently accessed workloads. However, as they belong to previous generation of the volumes, AWS recommends opting for cold HDD over the magnetic volumes. So in conclusion, understanding these EBS volume types allows users to make informed choices, optimizing performance and cost effectiveness for their cloud-based storage needs on AWS. Thank you.